She is Miss Dian Grueneich, and like most of us, Dian is a cardinal. She obtained her BA in Human Biology in 1977 from Stanford University, and her JD from Georgetown University. Dian is a nationally recognized expert in energy and environmental issues, with more than 33 years of experience. Her focus is on energy efficiency, climate change, renewable energy resources, transmission planning and permitting, demand response, and smart grids. Dian served as a commissioner of the California Public Utilities Commission, or CPUC, from 2005 until last year. While in this position, Dian was the lead commissioner on energy efficiency and demand response. She provided leadership for the development of the 2008 California Long-Term Energy Efficiency Strategic Plan, overseeing a 40% expansion of energy efficiency funding in 2009, which resulted in the current 3-year, $3.8 billion energy efficiency program of California investor-owned utilities. This is the largest program in the United States. She also focused on the adoption of California's net zero energy building goals, as well as the launch of Engage 360, the state's clean energy marketing outreach effort. An Energy Upgrade California, the state's home retrofit program. Dian was also the lead commissioner on transmission issues, overseeing the streamlining of California's transmission siting process and the successful permitting of 3 major transmission lines, resulting in more than $6 billion of new energy infrastructure to carry new renewable power. During her tenure, Dian helped establish the California Renewable Energy Transmission Initiative, the Parallel Western Renewable Energy Zone Initiative, and the Western Interconnections Regional Transmission Planning Process. She also served on the Transmission Expansion Planning Policy Committee of the Western Electricity Coordinating Council, the FERC-NERO Smart Response Collaborative, and the International CHP-DHC Collaborative sponsored by the International Energy Agency. Prior to her appointment to the CPUC, Dian served as a board member of the American Council for an Energy Efficient Economy and is a past president of the California League of Conservation Builders. Dian currently serves on the U.S. Department of Energy Electricity Advisory Committee, its Smart Grid Advisory Subcommittee, and the Leadership Council of the China-U.S. Energy Efficiency Alliance. Dian has recently joined Morrison & Foerster in San Francisco as a partner in the Environment and Energy practice. In the meantime, she also serves on the Advisory Council of Stanford Supreme Court Energy Institute. So it is a great pleasure to introduce the 2011 Shah family distinguished speaker.
Thank you. Thank you. I'm very, very pleased to be here this afternoon, and I especially want to extend my warm thanks to the Shah family, not just for letting me speak today, but also for the tremendous support that you've shown to the university for decades, and especially inspiring and helping so many students to graduate from Stanford and really have productive careers. So thank you so much. And I will just say that there was actually only one error, maybe others, but I graduated from Stanford in 1974 from the human biology program. And it is just, again, such a great honor to think that back the first day that I showed up at Stanford, being totally intimidated by the place, to think that through many people helping out and all of the network that happens when one does participate in an institution like this, that now here I am actually talking and being a distinguished lecturer. So I have many warm memories of Stanford, and again, I'm so happy to be here. I'm going to be talking about energy and buildings and smart buildings and energy efficiency, but one of the unifying themes of all of this is going to be catastrophic risk. And so a threshold question is, well, what is the connection? And I'm going to start off with the larger picture of catastrophic risk and energy. And there are many, many ways in which you can think of the relationship between energy and risk. I'll start with just before we even had to deal with climate change, just the natural events that occur in nature and how it impacts our energy system. One needs to look no further than what we are all dealing with now as a result of the earthquake and tsunami in Japan, and the major implications that it has, not just for the nuclear power plants in Japan, but for the entire energy system in Japan, where they're now looking at how are they going to be, in the short term, dealing with the electrical needs of the country, and then in the longer term, what is going to be their energy supply strategy. They just this week announced, the Japanese government, that in fact they're going to have a greater focus on energy efficiency and renewables. And so you can start to see the connection between risk and catastrophes, and then how it starts to play into the system that we think about with energy, and finally to energy efficiency, and that in many ways energy efficiency is a very smart approach, not just because it helps on the environment and not just because it's economical and can save money, but also as a risk mitigation measure. Then we're also dealing with climate change, and I'm not going to in any way, with the limited time today, try to talk about the impacts of climate change. I'm sure you're all aware of it, but again, study after study is demonstrating how vulnerable our current energy system is to climate change. Let me give an example. Just the rising levels of the ocean. Many power plants are located near the ocean levels. And this is going to have dramatic ramifications as we think about where is our energy supply coming from. Another area entirely of, as we think about risk and catastrophic risk, is the unfortunate threat with terrorism. A great deal of thought and planning is going on, not just in the United States, but throughout the world, of thinking about, in a system that we have with traditional energy, where we have large-scale power plants and major transmission lines, those are unfortunately vulnerable to terrorist attacks. And how do we protect ourselves from that risk? So this is just trying to give an understanding as a start to my talk this afternoon about when you think about risk and large-scale major risk, the energy system, not just in the United States but throughout the world, is actually at every level having to deal with what are the risk factors and how to mitigate. So now I'm going to switch into talking about energy, about buildings, and then what are some of the new steps that are going on in thinking about buildings, and what does that mean then as we start to think about risk and addressing risk and mitigating risk. So the parts that I'm going to talk through today are really just a basic review of energy and carbon impact from buildings, looking at the potential for change, which is very, very exciting. What in my mind are what I call the 4 pillars for major market transformation and how buildings are built and utilized, pathways to efficient buildings, Smart buildings, which is some of the most interesting work going on with technology as well as behavior change in terms of automation, demand response, and continuous commissioning. And then just ending a little bit of at least my personal thoughts on the future. So let me start with the U.S. buildings and where they stand with regard to global energy use. You can see there we go. You can see right here with the world energy consumption, the U.S. is approximately 20%. And this is energy, the most recent data that was available, basically published by the U.S. Department of Energy on buildings. It's 2008, so it's changed a bit that we really have China coming up a great deal as compared to the U.S. But when you look at the U.S. with world energy consumption, it's 20%. The buildings portion of this is actually about 40%. So that when you take the building portion out of the total U.S. consumption, you have U.S. buildings comprising 8% of the global primary energy use. And so this is something that I want to emphasize, why so much attention is being paid in the United States to how buildings use energy. Then when you look at it from the viewpoint of fossil fuels and carbon, you can see that on the fossil fuel side, the buildings are using about 76% of fossil fuel. Very little is yet coming from renewables. And in terms of carbon emissions, U.S. buildings are responsible for about 40% of the carbon emissions in the United States. So again, they don't always get the attention that vehicles get or some of the other issues in the energy area, but for those of us who are involved in energy, about the number one priority is actually to think about buildings and how we're going to change the use of energy in buildings, not just because of their energy use, but also because of the carbon emissions. This is just a quick snapshot of looking at then within the buildings themselves. As I said, buildings comprise about 40% of our energy use. You then look at industry and at transportation. Within the building use, you've got about 21% residential and 18% commercial. This chart breaks down the different usages in buildings, but again, the areas that are really where we are focusing are on lighting, heating, and cooling, with water usage in the residential side of importance as well. But again, to reemphasize, it's really the lighting and the heating and the cooling that are the major users of energy. But let me also take a moment to say of increasing importance is the use of what we call plug-in loads, which is all the gadgets and stuff that we have as part of our daily lives. The computers that we're using, the games that people are using, etc. The TVs. TVs have gotten much larger. In addition to getting larger, they're using a lot more energy. So a major area of focus is also looking at how are these loads that we plug into the outlets in buildings, how much energy are they using, and what can be done to either lower their use or control them so they are using less energy. So with that now, I want to talk about the potential for change. Buildings. I call this the grand challenge, though I want to give some reference also to Lawrence Berkeley National Lab. They run a really terrific buildings program under Steve Selkowitz, so some of the material today has come from LBNL. But the way that they think of it, which I very much agree with, is that you look at four major areas of focus. One is the life cycle of the building, and you can think about that, and I'll be talking about it later. You have a building that's designed. You then have a building that's constructed, operating, but we want to increasingly think about how we are able to be reusing the systems within the building, and then when the building is no longer being used, how is it being decommissioned? What's happening to the materials in it? We also then have as a second focus the integrated smart building systems, which I'll be talking about later. But this is increasingly an area of focus in the buildings world. It's looking at not just the materials, but then the devices that we put within the buildings. How can we integrate those systems? How can we then think of the entire building? And some of the most interesting work that's going on is how can we actually link together buildings into microgrids or a larger space of the electrical grid, and how do they operate together in a smart sense? The third area is a focus of intersection of technology and policy. And I'm going to talk about this more later on, but as an overview, and I can say this as a former regulator policymaker, energy is actually an area that is very heavily regulated. And government policies, frankly, can make or break new technologies. So thinking about and understanding the intersection between technology and policy is incredibly important. And this is where we can have innovative, brand new technologies come into the new space and be adopted or not adopted. Some of the best work that's going on in the entire world on occupant behavior, lifestyle, satisfaction, comfort is coming through Jim Sweeney, who just walked in, and the Precourt Energy Efficiency Center. And this is some of the most important work that can happen of thinking about how occupants use buildings and how they can respond to messages. And then we have investment and decision making, that technology does not come for free. A very important piece of the puzzle when we're thinking about how we're going to be changing the paradigm on buildings is what's going to attract investment. What do investors need to know in order to make their decisions on that investment? The last area is measurable, documented energy impacts. Energy efficiency is actually difficult for many, many people to grasp because it's the absence of something. People think about solar panels in large part, the studies show, because they can see a solar panel and sort of in their mind, and it's got connections to the sun. If I were to ask each of you, what do you think about with energy efficiency, it's very unknown. You might think about a compact fluorescent light bulb, but you probably would not think about insulation. Even though insulation is about the most basic thing one wants to do when looking at efficiency in a building. So how to understand the performance of buildings and what they are achieving is incredibly important. And some of the most cutting work is being done thinking about measuring performance and how to bring technology into this space. And then for thinking about it, that it's not just decision makers, policy makers, utilities that need to know what's happening within a building, but most importantly, it's the people who use those buildings, the people who design those buildings. So this comes together as the challenge that we have to all deal with when we think about the world of buildings and making them smarter and making them more efficient. Here's another way that you can think about, again, the challenge for the buildings. Basically, what we're trying to do in this area is to have what we call high-performance buildings, buildings that perform well and that also save energy. And we want to have this be a market advantage, not something that's viewed as more of a cost or a risk. So the players that we need to look at, or the stakeholders, are the manufacturers, architects, occupants, owners, and then the larger society, because all of these are entities that can benefit from having the smarter buildings. And this is, again, part of the complexity that we think about as we're moving into trying to build a new paradigm for making high-performance buildings. I'll just end with the business case for efficient buildings. This is really why I'm trying to show the great potential that we have for change in buildings. Remember at the outset I talked about that our buildings currently use about 40% of the energy. We can do a lot better. And there's the business case to be made. The operating costs can decrease significantly, and it depends again on whether you're dealing with a brand new building or retrofitting existing buildings. Here in the United States, we actually have built most of the buildings that we're going to have. We're still doing a lot of construction, but when you think about the entire country, the real hurdle that many of us are dealing with is how are we retrofitting existing buildings. In contrast, in the developing world, particularly in China, but also increasingly with India and other portions, they're looking at new buildings. But there's an intersection between the two, because many of the technologies that you develop and use in existing buildings will also be the ones, either as is or with modification, that will be used in new buildings. So we're constantly thinking about the interaction between the two. There have been a whole number of studies that have shown that when you put together efficient buildings, you increase the building value, you increase the investment return. Occupancy actually can increase. And then for buildings that are leased out, you're able to show increased rents. I don't have time this afternoon to go into the multiple barriers towards why don't we have efficiency, because I'm here to talk more about the technology and some of the ways that we can make major market transformations. But again, there's just a tremendous amount of work that's gone on to try to understand why, when we see the business case for efficient buildings, do we still not have the type of rapid change that we could have and we need to have. So what I've tried to do is, again, lay the groundwork for understanding that the potential for major changes in how buildings operate and use energy and emit carbons, this is an area that can really undergo market transformation. Here's another way of understanding it, that this is information from the U.S. Green Building Council that just shows the growth for non-residential green construction starts. Again, new buildings in the non-residential area that were green. Tremendous growth. You look at 2005, 2008, and then what's projected out in 2013. Another source has said that we're looking at this area growing from $71 billion projected this year to $173 billion by 2015. So the good news is that there is starting to be a very large-scale understanding of the opportunity to build really smart green buildings. Now let me move into what I call the 4 pillars for market transformation. In other words, you've seen that this can be done, you've seen the potential, how do we get there? Having been involved in this area for about over 30 years now, I absolutely believe that there is no magic bullet. In energy efficiency, we talk about it being the smartest thing to do. We talk about it being what's necessary for climate change. Many of you, I'm sure, have seen the McKinsey slide that shows energy efficiency is the one thing that you should start with. But energy efficiency in smart buildings only happens if you have a whole coordinated approach. So there really are 4 areas that you need to think about. The first are policy and standards. And what's interesting in this area is you have both the standards, absolute requirements. It is crazy to build an inefficient building in the United States in this day and age. The building is going to last 30, 40, 50 years, 100 years. You want to build it smart from the start. And this is true actually everywhere in the world, but especially in the United States, where we know how to build smart buildings. The absolute requirement needs to be very strong standards for building. California has been a leader. We have had Title 24 for over 30 years, and frankly, the rest of the country follows California year after year as we increase our standards. But you also want to have public policies that create a demand, that create a pull, and I'm going to talk a little bit about my experience of how we have tried to do that in California. A second component has to be the money. There is absolutely a role for public money to come into this space, particularly on demonstrating new technologies or buying down first costs. But then increasingly we are focused on the role of the private sector, how we are going to bring investment into this sector. And I will just say now, one of the interesting things that we're starting to see is the insurance companies actually looking at what's the difference between having smart buildings, buildings that are efficient, and what will be the savings in those buildings, and how those buildings can operate in a smart fashion versus dumb buildings. And this is one of the areas that I think can help us understand how private investment can be pulled into the world of the green building movement, because it gets back to a smarter building actually does mitigate risk on all levels, both in terms of how much energy it uses, but also just keeping the building operating in the fashion in which it was designed. The third are technology and programs that I'll be talking about, but you need to constantly be bringing into the system of buildings new technologies, new programs to have both the research, then the demonstration, and then the application to the wider market. And then the final area has to be performance and measurement of savings. And this has something that is part of a national and international effort now, that in the world of energy efficiency, there are no national standards really on how we measure energy efficiency. And even internationally, it's very fragmented. One of the most important areas is moving the United States towards national methodologies accepted at all levels for how we are measuring energy efficiency, and then coordinating those methodologies around the world. And then getting the word out on what does this mean in terms of carbon emission reductions, what does this mean in terms of savings for cost of operating or building the building. So these really are, unless you have efforts that pull all of these together, we're not going to be able to have this major transformation that we need to have in the world of buildings. I'm going to move into now just a snapshot to give some idea. LEED is sort of the basic standard that one has. There's a lot of controversy actually over LEED. Does it really measure and attribute the correct things? But this gives an understanding of, we do have LEED increasingly being seen as something that you design towards. Here's looking at it from the world, that we have increasingly around the world an understanding and acceptance that building green buildings makes sense. Now, making sure those buildings truly are green, making sure that during their lifetime they continue to operate efficiently is another issue. But we are seeing a great deal of looking at in North America, in South America, and other parts with the Green Building Councils. But we still obviously have large parts of the world where we want to bring them into essentially an international approach towards buildings. So I'm going to move now to what did we do in California of thinking about this area. I went on a study trip to Europe in 2007 on buildings and efficiency and spoke with officials in the European Union. And what I found out was that the European Union had directed each member country to develop an action plan on energy efficiency. So I came back to California and I talked with my colleagues and others and with the governor's office and said California needs a roadmap on where we are going with energy efficiency. We are known as the state that is the most aggressive in efficiency, but we need to really have something that sends the signal not just to decision makers and not just to utilities in the state, but to the private sector as well, where we are going on energy efficiency. So we have developed, 1 year later, the strategic plan on energy efficiency, and we just updated it. December, although it's January of this year, is an update where we put in a lot more information on lighting. And what this did was that we did a lot of public discussion and workshops, and we came out with what we called 4 big, bold strategies, because I really wanted to set the goal for let's do major challenges to where California can go, because California can lead the country and quite frankly can influence the world, especially in this area. So we have 4 strategies now in California that have been incorporated in the policy in the state, are moving into law, and the programs that are funded by the public sector monies run by the utilities now are all lined up with this. 2 of these are for zero net energy that I'll explain in a minute, and they're part of a worldwide movement that I wanted to align what we're doing in California with what's happening internationally. So for the new homes, all new homes being zero net energy by 2025, all new commercial construction by 2030, and the print here is too small, but the others are that in the HVAC area, which is heating, ventilation, and air conditioning, that we will transform that industry to again be more efficient. And there are final areas in low income. As a commissioner, I oversaw the low-income energy programs in California, and I felt very strongly that we need to make sure that our movement towards energy efficiency was not just viewed as something for rich people, but needed to really work for everyone. So one of the best policies that the state has is that by 2020, every low-income resident in California who wants to benefit from energy efficiency, this is voluntary, and who qualifies under our low-income guidelines, will receive the full suite of energy efficiency programs in California at no cost whatsoever. We adopted that policy, and then we doubled the budgets that we have for the low-income programs. And I'm very happy to say, and then we divvied it up that we would get to this goal in increments of 25% each cycle to get to 2020. And California is on target. We doubled the number in 1 year of low-income residents that then qualified and had done low-income energy efficiency measures in their apartments and in their homes. So this is an example where by putting together the policies, the funding, thinking through the technology, thinking through the measurement, we were able to really transform what our low-income residences in California are going to look like. So let me move on to zero net energy. As I said, this is another area where California is leading the country. There's only one other state, Massachusetts, that now has a similar goal, though the United States Department of Energy also recognizes the importance of this and is funding a lot of efforts in this area. But you basically think of it as having as much energy efficiency as possible so that you are driving down the usage in the building. And then you look at having distributed renewable generation either on the building or nearby so that during most of the time that the building is being used, you actually don't have it taking power from the electrical grid. And then there will be portions of times where you have your energy usage decline, but you still have the renewable generation, and that's actually selling back into the grid. And this is the vision that we have for California, and as I said, for many places around the world, of this is how we are going to have our new paradigm on energy usage in buildings. This is what we have as our path to zero. I don't have enough time, and I'm not going to try to actually run through the details, but basically we now have a very organized effort in California where we're simultaneously both funding and supporting and monitoring 3 different levels between bronze, silver, and gold so that we are driving up over time the stringency of our energy savings. And we're doing it through a combination of mandatory requirements of what are going to be the building standards in California, as well as what are the rebates given from the utility programs and for others to bring in the new technologies to demonstrate how the buildings operate and then continuously innovate and change the technology over time. How are we going to do this? This is just a sample of some of the different ways and the tools that we use for smart buildings. Looking at energy efficiency, heating and ventilating and air conditioning. Looking at water efficient plumbing. Looking at improved lighting and appliances. Looking at the building envelope, basically the building shell, how we can do it. And then looking at the monitoring and how the building is reacting. These are all, when you're looking at smart buildings, you want to think about and be bringing into the building. So let me now move into the bigger picture, which is, and this is something that I hope that I can leave, frankly, a sense of excitement with, because when I bring it back to the basic theme of, is this an area where we can reduce risk? The answer is yes. But I firmly believe it's because we are looking at this in an integrated fashion. and that we're starting with just what are materials. And you can have smart glass, and you can have very efficient windows, and you can be looking at your lighting. But then you want to take it down into understanding how are you incorporating it within the area of the entire controls and sensors and networks. How is that then reaching out into the electric grid, and can your building actually be a source for storage as we are moving to more and more use of renewables on our larger electric grid? And that to me is where we're going to have the interaction between having smart buildings, buildings that are efficient, with can we then use them as a tool in which we can minimize risk in our energy system. But it's going to be dependent upon not just doing the basics of what we call widgets of insulation and lighting, but building into the buildings a whole IT, information technology structure that can communicate back to the grid. I also wanted to talk about as another part of what we look at buildings, and these are energy certificates. And this gets back to what I talked about with how do you truly transform the market in efficient buildings. It's not just mandatory standards. It's also understanding that people are human and people react to information. Automation is essential, but there's going to be some level of creating a demand. And in Europe, they've now operated for about 7 years with energy labeling certificates on their buildings, which go all the way from, as you can see, low energy usage to higher energy usage. And you can literally walk up and see on the outside of commercial buildings what its rating is. And what this is demonstrating over time is that it is actually creating an understanding and awareness by the public as well as by the major players that there is usage, great energy usage in the building, and how that building uses energy matters. California has passed a law a couple of years ago, so we are set to embark upon a similar type of labeling. And then what's interesting is you can actually get into thinking about how do you do asset rating among a block of buildings, where does a building stand? And then what we want to eventually get into is the operational labeling. One of the concepts to understand with buildings is that buildings, even though they are fixed physically, they are not static in time. They're systems that are built into the buildings, decline over time, deteriorate over time, no longer operate over time. And then you add on top of it, buildings are used by people. People come into the buildings and they have their own plug-in loads, they change the thermostats, they block the vents, etc. So a major effort has to be thinking about buildings dynamically, not just when they're built, but how are the occupants using them, and then how are you understanding how they actually operate, and how are they operating in comparison to other buildings. So let me have as the next area that I'm going to talk to what I call automation, demand response, continuous commissioning. And this is the area where we're really talking about using smart technology, using innovation. Building commissioning is basically when you build the building and first occupy it, or before you occupy it, are the systems basically working? Something that was the way that people looked at buildings over time. Retro commissioning then evolved as let's go back into a building sometime later, maybe 10 years later, maybe 20 years later, and actually see how that building is performing. And then it tuned everything up in that moment in time. Well, of course, you know what would happen is the building then continues to decline in its performance the moment the retro commissioning is done. Monitoring-based commissioning is then trying to monitor what is happening to understand how things are declining over time. But where things are really moving now in the whole world of buildings is towards automated continuous commissioning. And this is building into the building either when it first is built or when you are doing some sort of a retrofit of a building to have smart sensors, smart technology built into the building so that you can have basically the building self-correcting itself, doing diagnostics, and staying as efficient as possible in time. And this, again, bring back to one of the themes about risk. If you think about risk being what is the building cost? Is it really going to be generating savings that we had? If somebody's trying to actually over a 20-year period budget for how much they might have to spend on the electricity use in the building, if you have an understanding of how buildings operate, because we have built up a really good database and understanding of what happens to buildings over their performance of time, that's one thing to understand risks. But then if you take it the next step further and we make buildings so that they are smart and they stay smart, you are then really able to make sure that whatever was promised in terms of what were the costs of that building or what was the performance of that building is going to stay over time. And to me, this is the vision of what we're looking for when we talk about what is the major market transformation that we want to make in buildings. These are some of the diagrams, again, from Lawrence Berkeley National Lab and its work on buildings that I will not try to go into. But you can see that they are taking and looking at every level within a building. How are you building the most efficient devices and efficiency in the building? But then how are you layering on top of it integrated controls with real-time modeling, fault diagnostics, optimization? And then, what's very interesting, how are you connecting that within buildings, other buildings, and how are you then thinking about under what we call real-time pricing, that where you have the energy, the price that people pay for electricity changes in real time because it costs different to produce electricity at different times of the day and at different times of the year. So that you actually could have a building understand what those real-time pricing signals are, and if you've built your sensors in, you can have the usage in that building change automatically, not noticeable to the occupants, but take advantage of the real-time pricing so that you start to actually maximize what can be the either income that you get from that building or minimize how much electricity that is used. And this again is some of the great opportunities that we have when we start to think of buildings as integrated wholes and as part of the system, and it's directly linked to the larger electrical use that makes it so exciting of where we can go with buildings. Here's another way that we can look at the whole building and the life cycle, that we have retrofit. How can you go into a building and make it so that it's more efficient? How are you going to look at the maintenance? How are you going to install in building the automated diagnostic tools so that your operations makes the most sense? How are you going to design the building? How are you going to construct it? What's the commissioning and what's the occupancy? All of these are interrelated, and all of these have to be thought about as we're thinking about the paradigm of how are we really getting towards a world of smart buildings. And as I said before, it's information monitoring and diagnostic that's going to be a huge tool that we can use. But I again want to emphasize another important area is behavior and understanding how people react to different changes within the building. Understand on another level what is going to cause architects to really design these types of buildings. Understanding how we have the financial community say this is an area to invest in. And all of this is not just because we have great information, but because we're also doing much better research and understanding how do people make decisions in areas that are related to energy, and what are the best tools we can use for having them have the information to make the smart decisions. So again, we've got, and this is one reason why after 30 years I continue to love energy, because you have the whole technology component, you have the policy component, but then you have the human component of how we think about people react in the real world to all of these complex issues. Here is my last slide, again showing the future of the smart buildings, which we are looking at bringing in the diagnostic. What's the feedback? How are you having energy managers in buildings? But then having it go out into the larger system, which can then go out into the grid. And all of this is work that's going on, certainly here at Stanford, at the Lawrence Berkeley National Lab, Building Center, and around the world. And we are going to see such innovation coming into buildings. I absolutely believe in the next decade that is going to make seem like what we've done in the last 100 years was nothing. That this is really the pace of change, because we are starting to do not just more funding of this work, but we're really starting to use the ability that we have with the IT arena in a way that we were never able to use it before. I just have a minute to talk about demand response, which is an area that I think is going to be huge for buildings of the future. Demand response is basically the concept that energy efficiency is the concept that you want to try and use less energy. Demand response is, well, you want to try and shift when you use the energy. And that gets back to the way power plants operate and the grid operates, that you have a time of the day and a time of the year where more energy is used. Typically, if it's the summertime, people come home from work and they're turning on the air conditioning. Maybe they're starting to cook meals, maybe do a load of laundry, and you still have people in the building running the buildings. That's creating a peak both in the summer and in the 5 to 7 p.m. hours. Utilities build power plants just for that period so that we don't have blackouts. Those are tremendously expensive power plants to build. They're the most expensive thing on the system. Demand response is a concept that says, well, the thing to do is actually to build in ways that the usage of energy is shifted to other times so that we have a flatter load. And automated demand response is a concept that we can build in small changes, small decreases, say, in what's the load of a refrigerator when it's doing its cooling, what's going to be the air conditioner, what's going to be the lighting in the building, and that it happens automatically. And that most importantly, in terms of having the payback into the system, that in the larger energy grid that we have what are called wholesale markets, where if you are a power plant owner, you can bid the output of that power plant into the market and you get paid. Some of the most progressive work that's now being done is having demand response be a product in the wholesale market, so that when you basically bid in, that you can reduce demand at a certain hour of a certain day, and it's usually just done on a day-ahead basis, there will be a payment back. And we have companies now that are making an entire business model off of this. The world that we are going to move into, I think, extremely quickly is automated demand response, where you are building the sensors and the controls into the buildings, and where those buildings are able to be getting the price signal, and you're able to be getting the small shifts in the energy usage in the building, and that then generates an actual value stream, a payment stream, back to the building owners, back to the building occupants. And one of the areas that's being done is to have it be an open platform, which is called open ADR, so that we basically have a system set up that is non-proprietary, that is available to basically be used by everybody who wants to participate, and then you have the proprietary systems that will hook into that, be built as well, so that there's a business model for the companies that want to innovate in this space. But having the open ADR, where we have a basic architecture in this area that's non-proprietary, is incredibly important. So I'm just going to close with a few thoughts on the world of the future, which in many ways is here, and why I remain so excited about buildings and energy efficiency in general, but this whole area of the smart grid and looking at the demand side. We have tremendous potential in this area. People like to live in buildings that work well. Everybody's been in a building that overheats, and then you open the window and you feel slightly guilty because you've got the window open, but you're dying because the room is so hot. We don't need to live in that world. We have the technology, we have the ability to have smart buildings that have people comfortable in those buildings. We have the ability, and we're increasingly improving our technology, that for building owners, they can have a value stream from having these types of efficient buildings. And then with our planet and with climate change, in my mind, we really have no choice. This is something that is critical to address how we are building, operating, monitoring buildings, and this is something that we need to do absolutely if we're going to address climate change. So I'm just going to end on one quick snapshot view of China. Anybody who works in energy efficiency or buildings knows that China is an absolute issue to deal with. As people say, we could do all the energy efficiency in the United States. We can make every building zero net energy. And unless China also is embarked upon that same path, we're not going to be able to address climate change. The statistic that we have, I think, is that China every 3 years is building the equivalent of the entire building space in the United States. I mean, it's just a massive amount of energy building that's going on. But we have, in my mind, a great deal of leadership from China as well. They just recently released their 12th fifth-year plan, and that has the combination of the policies, frankly, the money commitment, and then looking at specific programs. And in the area of new buildings and retrofit, we have an awful lot of work by China that's going on in this area. Just last week, there was a delegation from China at its highest levels, the NDRC, the National Development Reform Commission, that came to the Bay Area and is in Washington this week. 200 top-level officials from China, as well as companies in China that are investing in the energy efficiency and building space. 200 officials and other important stakeholders came to learn and understand and to share information on energy efficiency in buildings. I first started working with and understanding what China was doing on buildings when I was appointed as a commissioner in 2005. And back then it was, you know, maybe a handful of exchanges. And to see this level of interest from China gives me a great deal of hope. But I wanted to make sure that I did end with, we all in the world of energy efficiency in buildings want to think about this as it's not just what we are doing right here in California, and it is not just what we are doing in the United States. That this is a global issue that we're embarked upon, and these are going to be global solutions, and that many of the new technologies, many of the new innovations are not just going to be coming from us outward. I truly believe that we're going to be learning from other countries and sharing the information. So with that, I'm going to conclude. I just want to say thank you, and I'm going to tie it back to the risk aspect, that I believe that when you look at the energy sector, as I said, with the amount of electricity used by buildings as well as the carbon emissions, we have to think about how we're going to make those buildings smarter. And because of the way we're going to make buildings smarter is we're actually going to embed within them better ways that they are going to operate with more technology that will then communicate back to the grid. I think that that is a way that we're going to be looking at mitigating risk in fundamental ways from having the type of basically dumb buildings that we have now. So thank you very much. Did you? Okay.
Many thanks for the enlightening lecture. The floor is now open for questions.
I have a question. I'm loud. Don't worry. I have a question about the idea of the zero net energy building for both residential and commercial. Mm-hmm. So, I don't know if I need this. Is that met with resistance by the utility companies? Because essentially, by doing that, you're taking away their product, right? They have no one else to sell it to if there's zero net energy.
The utilities, can you all hear me? I realized I was talking without a mic, so hopefully you weren't sitting there politely the whole time, not hearing me. Now you can really hear me. The utilities did not oppose our putting this policy in place. And in fact, we have in California mechanisms by which the utilities can actually make money for their shareholders if they achieve the energy efficiency goals. And so we've set up a system in which the utilities respond to doing energy efficiency. But you absolutely have hit upon what I think is a fundamental issue yet to be grappled with, which is if all the buildings are basically producing energy rather than buying electricity, what is the business model for utilities? And I think that this, again, is something that the utilities are going to have to deal with. I personally think that we're going to end up with a vastly different system than what we have now 20 years, 30 years from now as we move into really efficient buildings, and that it's going to be much more a role of utilities where they are owning the large-scale power plants, because we will continue to have some. They may be renewable for stability of the grid. And then you will have the smaller distribution systems, because again, there still will be probably interconnections at the distribution level. But we will see, I think, very dramatic changes in what the business model is for the utilities. Any other questions? Here,
First of all, thank you. But second of all, you did not talk about the occupancy of buildings, and by far the most efficient building typically is one that's empty. It's not energy efficient at all.
I know.
The second thing is, depending on how we site the building, the transportation costs change entirely. And I guess it was conspicuous that you looked at the building itself, but not the broader zoning question. I was wondering if you could just comment about any relationships, both theoretically and practically, between the zoning and the buildings themselves.
I totally agree with, I think, with where you're going with the question, which is one wants to think about energy in an entire ecosystem, essentially, which is as we basically leave our homes, the first question is, are we leaving our homes to go to work? Another question is, if we are doing that, how are we doing it, and what energy is it taking to get where we are working? And then once we are working there, what energy we are using, etc. And the larger system of looking at energy absolutely needs to think that through, because if you are able to have the buildings near the mass transit, that obviously is saving the energy in a much larger scale than if you have the people driving to the building. So I didn't put it in because there's sort of a larger picture to start to get into, and I really was focused on the buildings themselves, but that's very important of thinking about how are you placing the buildings within the community, and then what is the usage not just of energy, but of of all the other aspects of our environment that are impacted by how you're getting to and from the buildings.
Diane, thank you for a very informative lecture, and thank you for your wonderful service on the Energy Commission and doing all these great things for California and for the world. You talked about people. You talked about policies, funding, and people. And it's one thing to influence the behavior of people one at a time, but people also create these wonderful social institutions like craft labor unions and subcontractor specialties and approaches to commissioning for building that give general contractors a certain markup that is enough to maybe commission a standard building. A highway, you just cut a ribbon. A standard building is somewhere in between cutting a ribbon and industrial commissioning. But these institutions change very, very slowly, and they're very resistant. And so the fact that developers lease out buildings triple net takes away a lot of the incentive for them to improve energy. And they do that because the financial institutions didn't want them to accept the risk of energy price fluctuations back in the 70s. And they stopped offering loans on commercial real estate where the developer had the utility risk. So all these things need to change also. And some of them can be affected by companies developing new business models, people like Solar City and so on, where they arbitrage the the broken agency or displaced agency, and that they own the solar collector on your roof instead of a homeowner who only lives in the house for a few years. But I think there are also changes that need to happen in the way the industry is structured, and we see firms like Johnson Controls, for example, integrating 200 specialty contractor disciplines so they can actually build an integrated control system that works, unlike the ones in some buildings close to here that I won't mention that took 2 years to begin to perform the way they were supposed to because no one knew how to commission them, and they were built by so many separate firms who never worked together before. What's your thought on the way we can influence those kinds of things?
Again, I think you've hit upon a very important part, that getting back to one of my points, that in order to achieve accomplishments in energy efficiency, you are constantly, and I'm just amazed at this, constantly pulling together lots of different things and lots of different silos. I focused on within a building, in order to make a building smart and to stay smart over its lifetime, you know, it's really looking at a whole number of different aspects. But you're right, in order to actually get the smart building done, it is taking what is a whole host of different people who are designing different parts of systems, and yet we don't have a structure necessarily in which somebody is in charge of stepping back and saying, is this the most efficient system, and what can we do? I'm, as I said before, I'm an optimist. You do see Johnson Controls. I mean, we're seeing the very large companies who are stepping up to the plate because they are understanding internationally, frankly, they're going to make profits if they are able to develop these much better integrated, much better efficient systems. I also think that we have the tool of the internet, and the fact that we're going to be able to exchange information about this is a smart way of having the different crafts pulled together in the systems. But it is going to be, there is no silver bullet in this area. And part of the concern that many of us have is that we've had great leadership in the area of energy efficiency under Secretary Chu and President Obama, and we had the federal stimulus money coming in, and a great amount of money has been put into energy efficiency and building work. I mean, Secretary Chu understands buildings, but with the end of the stimulus money, will we be having that same leadership at the federal level, which quite frankly is a lot of funding? And if not, how are we going to be able to sustain these programs? And certainly I think we're going to see a lot of work with the private sector, but it's very hard to envision us moving to this future if we don't have that leadership at the national level.
Thanks very much for a very informative talk. Also, thanks very much for putting together Energy Upgrade California and doing marketing and outreach. I had a specific question about contractors, because I spent the morning talking to a group of contractors, trying to persuade them to become participating contractors under the Energy Upgrade California. And many of them have no idea about whole house concept, the idea that to get the kind of energy efficiency improvements in existing buildings, that you need to treat the house as a whole. And I was wondering what thoughts you had about, I mean, I think I talked to someone who trains in this area, and he said it takes about 3 days before the light goes on in a lot of these guys' minds about what's happening. So you still have lots of people, furnace, HVAC people selling a big new furnace when they should put some insulation in the house walls. And I wondered what kind of thoughts you had about transforming that particular barrier.
Should I repeat? There is no silver bullet. For the rest of the audience, Energy Upgrade California is California's home retrofit program, and I believe it is the largest in the country. I also co-chair the residential retrofit working group nationally that is looking at the various retrofit programs going on in the United States and sharing lessons learned and best practices and how do we accelerate. What the gentleman was talking about was that the basic concept is when you go in and do something in a home as well as a building, it makes sense to try to really not just do the minor changes, but our standard in California is we want an average of at least 20% savings overall on homes that have a retrofit done to them. And frankly, we'd like to move to 30%. And so what this means is when you have somebody come into the home, we're trying to create a sense that this is a home performance contractor industry, that whoever comes into the home understands and can do the assessment of the entire home and isn't interested in just selling you one single thing like a furnace, but we'll look at the entire home. And I actually have a story that if we have time, that I'll tell, which is I've obviously been doing efficiency for a long time. I actually worked in the first Jerry Brown administration. And when Energy Upgrade California was launched last year, I said, well, we better get our home energy audit done, and I better get our home retrofit. And we live in a beautiful Julia Morgan house in Berkeley, and my husband and I have prided ourselves that we have bought the most efficient appliances totally. That when our furnace broke down a few years ago, we got, the super efficient furnace, and when we renovated the kitchen, we put in the double pane glasses, and we put in, the dishwasher, and everything. We did all this great, and so I'm thinking, okay, we've got it done. Well, we have our audit last year in which they come out, and because it was a trained performance contractor, they did the serious assessment of the house, and lo and behold, because it is an old house, the insulation in the attic was put in 30 years ago. So that we have been busy heating the outdoor of our house with our very efficient furnace. And sort of on every level, it was like, this is real. Don't tell the story. This is really embarrassing. But here I am, talking about this, and we had never done it. But what was really telling was that when we had our kitchen remodeled, it was a contractor, and they put in, because in Title 24, when you remodel an area of the house, they have to bring it up to the Title 24 standards. So they carefully put in insulation under the floor of our house with the kitchen, but they at no time noticed, told us that, by the way, you don't have any floor insulation if you walk 5 feet down to your living room. Nor did they ask us or see as a business opportunity, oh, I wonder if you have ceiling insulation. Could we check on it, and we'd like to sell it to you? And this is what we're trying, and the same thing with the furnace installation. Came in, put in a wonderful furnace, put in the insulation, the duct protection right there, but again, did not see it as their business model. Well, why don't we ask them how their whole home is performing, and we could sell them products. And this is what our challenge is. I think that we're making progress because we are educating the contractors. There's real business opportunity. And I'm also a believer of there's value here. I mean, once people start to understand that your home is a whole system, and it makes sense if you're getting one thing done to at least understand the other things. And then if we set up the financing mechanism so that you can actually afford to have it done, this is going to take hold. And as we bring in the social networking, the community, so I can say to my neighbor, you're never going to believe this, but when I had the furnace put in, they talked to me about the ceiling insulation. We had this great financing program, and now our electricity bill has gone down. And to have that area where we can have the information communicated as well. It's not going to happen overnight, but I really do believe we are going to change because these things make economic sense when it comes down to it. Only if it's an easy question, Jim.
What companies now are doing that well? That whole home understanding, retrofitting, and contracting. Solar City, for example.
How about if I take that question offline?
Fair enough.
Any other questions?
Hi, thank you very much for the speech today. And I saw some
zero carbon house in Shanghai Expo last year. It's built by London. It just show us their new structure system. Not just like zero energy, they also try to achieve the zero waste. Like they try to use regenerate energy from human, maybe inside the building by their movement or something. Mm-hmm. So can you introduce us a little more about this?
I'm actually not familiar with that building, but it is part of a whole movement that's going on, which is to understand how the buildings are built. We can make very efficient building, and then how are we able to have other systems that can produce the energy. Again, I'm not familiar with the technology that they used. And I'll say that part of this also needs to look at, I've talked about the energy, but the water usage is very important, and so you want to think about the entire usage of all aspects of the building and what could be done to minimize it. But again, I'm just not familiar with that example.
Because I think it's very hard to control what the occupancy will behave. So maybe it's better way like use their movement, because I think it's very hard to control the behavior of people when they live in that building. So maybe it's better to use them and not like control them. Thank you very much.
Hi, thank you. Thank you for the presentation. Mm-hmm. I want to know if the California Public Utilities Commission had, with all these efforts in energy savings, came to associate with the structural engineers, because for a building to be zero net energy efficient, it's a very good thing, but especially in California, if you are hit by an earthquake and your buildings is destroyed by the earthquake, or the non-structural components are your solar panels fell off, how that is taken care of, or is there like any talk between the FEMA regulations agencies, or is there any talk between the energy commissions and the public policies makers of standards and codes?
I'll go back and check on that because I mean that is a good point. Of there was, let me say two things. First of all, it is not a law in California that new buildings need to be zero net energy. That I thought it was actually very important that we have a number of years where we are funding and measuring what do these buildings look like, how much do they cost, how do they perform. And then we will move towards actually putting this in law, because we have to understand what is the structural performance of these buildings as well. So then the other part is my takeaway is I'll go back and check and see, sort of the it's a large stakeholder group that is embarked upon this zero net energy in California, and I would hope that structural engineers know about it and are starting to get involved, but I can certainly double check on that.
So I have a question on measurement and verification. So it's a little specific, but so basically measurement and verification is what tells us whether an energy efficiency project has been successful or not. And I spent the last summer working on this subject during my internship, and I realized most of the energy service companies who do energy efficiency projects to buildings, they also provide the measurement and verification of those projects. So that's a very clear conflict of interest, I think, because they're also the equipment manufacturers, and it's good for them to actually inflate those figures and say, look, our products and our services have actually saved you a lot for your building. So my question is, do you think the data is reliable out there, that because you're making policies, plans, and you're looking at all of these data and seeing that the buildings are efficient, but are they really efficient? That's my question. Do you think that how important is this problem?
I am a strong believer that you need independent third-party measurement and verification. And there's two things. One is here in California, if it is a project that is partially funded by a rebate or a subsidy from the local utility, then that utility is required to have some sort of third-party verification. So it's not just somebody relying upon a statement from whoever is selling them that service that you're going to get the savings. And the theory is because if it's using public money, we want to make sure that the savings are occurring as promised. And then the second aspect that we have in California is that beyond what the utilities do, because this is such a large amount of money, I mean, we're now at the stage of it's $1.3 billion a year of what we call ratepayer money, small charges on everybody's electric and natural gas bill that's funding these programs. The state of California does independent measurement as well. So it's not just relying upon the utilities, and it's certainly not just relying upon promises by the companies who install the measures.
Thanks for the talk. It was really good. You had mentioned that a lot of your background is in transmission as well. And you obviously know a great deal about the transmission problems in the state. And it seems there is a connection between building efficiency and having to build less transmission lines, which tends to be really hard to do. Can you talk a little bit about the connection between transmission in the state, the need for more transmission, and the role that buildings could play in helping to abate that problem?
Sure. On one level in California, we actually approach it very methodically in that there are energy efficiency saving goals that the state has adopted for every utility in California that go out at least 10 years, and you can extrapolate out 20 years if need be. And we have a policy in California called the loading order, which says that the number one thing that the state does is energy efficiency or demand response, and that's what we try to do as the first thing. So that when we do transmission planning in California, we actually, where we're forecasting what are the needs for that transmission, you start with a forecast of where you think your electrical loads will be your forecast. You build into that what you think are the energy efficiency savings, so that you are then only looking at what is the incremental load that you would need to meet load growth, or for renewable energy, which is a little bit more difficult where you'd need to go. When I was a commissioner, I was part of a larger transmission planning effort in the entire Western interconnection, that the United States has its electrical grid where there's the Western interconnection, the Eastern interconnection, and then Texas gets its own interconnection called ERCOT. But there's interconnected grids in the West and the East, and as I said, Texas. And so I was part of a very large-scale planning effort in the West that had been funded by the federal stimulus dollars. And I was asked to be, and then chaired, a demand-side management committee to be assisting in that transmission expansion planning effort. And with the assistance of Lawrence Berkeley National Lab, we methodically gathered together either what were the state level requirements or utility goals for energy efficiency everywhere in the Western United States. And we then compared that, and these were not pie in the sky. I mean, these were actual laws that were required or programs that were funded by utilities. We then compared it with what were the forecasts that the Western Interconnection Coordinating Council, which is the entity that keeps the grid running in the United States, was using. And we discovered that there had been no connection between the two, and that there was about an 8% difference. So you can think about that there was about an 8% overbuilding or overplanning for transmission, simply because nobody had asked the question, does your forecast include energy efficiency? And one of the things that I'm actually most proud of is that we've now brought that into the official planning that's going on so that we are having energy efficiency relate to the transmission that's being planned for and built.
Okay, in the spirit of time, let me ask a final short question.
Oh, you get one.
What is your view on how you can engage the academic community into this endeavor, apart from teaching classes here and there?
Well, first of all, everybody get excited about energy. Everybody get excited about energy efficiency and the demand side. It's a great future. You can be in any sort of academic discipline that you want to be in. But on another level, there's so many ways to engage, especially here at Stanford. The Stanford students have a Stanford Energy Club because they put on a big presentation with Berkeley a couple of months ago that I spoke at, and students can get involved in planning and helping and make that happen. There are, I think, 3 or 4 different research centers now operating at Stanford in the energy area. You know, take the courses, demand that the courses happen, whatever is appropriate here at Stanford. But I also think of it as we're all part of you know, this movement or whatever, that one of the messages I would leave with students is that there's nobody in charge of saving this world. And even if there were, it only happens because everybody steps outside of their comfort box and says, what sort of change could I make? And I had the great opportunity as a commissioner to have very good advice from one of my mentors, Art Rosenfeld, who is the grandfather of energy efficiency and a very good friend. And he said, be very focused when you are a commissioner on what you want to do. And I decided that if I could be the lead commissioner, which I was luckily appointed to be on energy efficiency, I would push the envelope. And that's why when I came back from Europe and said we're going to have a roadmap, the staff went, oh no. And then when I came back and said we're going to do zero net energy, but it was a really part of everybody has a way, I think, of making a change. And in this area, everybody can end up in ways that we never expected, making very significant changes. Get that retrofit done in your home if you live in a home. Talk to your neighbors about it. If you're working on an exciting technology and you're not sure how on earth it could ever be employed, you know, don't be passive and wait for somebody to figure it out for you. Figure it out on your own. Talk to people. Get excited about it and keep on pushing the envelope. So that's what I'm going to leave it with, which is everybody figure out how you could make a difference and then really do make that difference, because this is a great platform for doing it in.